Reciprocity is, you can view it as the S parameter being symmetric. Yeah, my Sij is the same as Sji. That means I have S11, S12, S21, S22. So this term and this term are the same. If these two are equal, then you call this system to be a reciprocal system. That means if I inject A1 and if I get a certain B2, if I were to inject the same A1 to be the A2 here, then I would get the same B2 as B1 here. So that's a reciprocal system. If for a certain A1 you get a B2, you inject the same A1 on the port 2 as A2, then what you get out at port 1, which is B1, is going to be the same as what you previously had as B2. So that's reciprocal. So passive networks with isotropic materials are reciprocal. Isotropic, for the moment, take it as materials that does not behave on the direction of power flow. Whether the power flows in this direction, it behaves the same as the power flows in the other direction. It behaves the same. Then comes a symmetric network. When this two, when this guy and this guy, when they are the same, when Sii equal to Sjj, and when Sii as Sij is equal to Sji, so this guy alone is a reciprocal network. But if this additional condition is true, then it becomes a symmetric network. If I swap port 1 and 2, I have no problem. 1 and 2 is just a name I give. 1 can be 2 and 2 can be 1. That means it's a symmetric system because this is the same as this and this is the same as this. And the last property, which is very important for a passive lossless network, the S matrix is unitary. A complex matrix S is said to be unitary if S transpose S conjugate is equal to identity matrix. By, for example, identity is 1001 law. So this is an identity matrix. So this is general expression is for a 2 by 2. You notice that S11 plus S12 square is equal to 1. And this term is going to be equal to 0. Because it is lossless, what is reflected at 1 and what is transmitted to 2 add up to 1. Because it's lossless, what is reflected at 2 and what is transmitted to 1 add up to become 1. Because there's no loss in the system.